Good afternoon, everyone. Remember me, I was the first one to greet you good morning, right? And now I'm greeting you good afternoon and nearly good evening. So actually, I'm the security guard of Singapore Poly. Open and close shop. Okay, before I start, let me just open my slide. Okay, before I start this, I'd like to congratulate every one of you for making it up all this way. The feeling was like running 600 kilometers to KL, right? Okay, but you made it, and I think it was a good seminar. It gave us a lot of knowledge and overview about different topics, right? So that was really good. And then another thing is, I'd like to thank Mr. To from Simtech because he did the preliminary talk of my topic. Wow. And actually, I am not a businessman. I am not a PhD. I'm just a layman or maybe an engineer like you. So the way I understand the smart factory hopefully resonates with most of you here. Are you all here engineers or bosses? Or businessmen? Who are engineers? Yeah, okay, this is my crowd. Okay, so at the end of this topic, at least the engineers and the managers also will have some idea. The engineers can go back to their factory and immediately implement some IIoT. Okay, so that's the goal of my seminar. Okay, let me proceed now. But let me correct this a bit. Okay, let me correct it to Smart Factory IIoT solution. Okay, I'm not in IoT, rather IIoT. Okay, the contents of these topics would be, firstly, the big picture. But I think my big picture is now smaller compared to Mr. To. He has the bigger picture. He's the businessman, he's the policymaker. So mine is slightly big, slightly small actually, relative to him. Likewise, the benefits of this thing, the E1, the flexy, which is actually a product of TDS. Okay? So, the next slide that I will show you is my interpretation of a smart factory. Okay? Then again, hope you relate to this. Okay, we start with your factory, right? You have a conveyor with boxes with machines, right? This one you can connect. We are typically familiar with this control loop, wherein we count the number of boxes on the conveyor, right? We send this sensor information of a 1 or a 0 to a controller. The controller then counts 1, 2, 3, 4, 5 boxes. Because we have a setting on a counter like 100, after 100 times, I'm going to tell my conveyor to stop. You're just going to run 100 times. And this is what we are familiar. Sensors, controllers, outputs, conveyors, right? Okay, now, if we make it a smart factory, okay, wherein this is actually a component of a smart factory, in my interpretation, it would be like this. Okay, we're going to add this new control loop. What is that? That is what Mr. To said, like a business insight. Wherein, yes, I do my normal control loop, but somehow I go to the cloud, because the cloud has a lot of information there, pull for some prices, maybe from some website or some server, who knows what the current electricity prices are right now, and then maybe do a forecasting or simply know what the current electricity price is now. I'm going to feed that information back to my factory, okay? And instead of telling my conveyor to run 100 times, I'm also going to include the business insight of, you know what? I think you don't run today. Electricity prices today are high. I think you should better run tomorrow, right? Or, since my forecasting, my analytics is so good, I think this month you all go to holiday. Prices are high. Okay? Don't run. Okay, this is what I understand about IoT in an engineer's perspective. So for me, the smart factory knows when resources are high. Okay? So we can optimize more our operations, right? We can also ask the same question that maybe oil prices are high. I don't want to lubricate my machine because lubricating oil now is high, right? But this one doesn't happen with what Mr. So said. Manually now, we're in, okay, you have on your headquarters supply chain people, right? Managers, a lot of staff. Okay, we detected that the price is high. Pass to another manager, pass to another manager, pass to another manager, until it arrives to the factory manager, until it arrives in the engineer, to the controller, and says, hey, slow down, set the PLC to stop working, right? This is a manual way. Now what will happen is, it will automatically talk by itself. Cloud and factory, they all seamlessly connect and happen real time at business speeds. Okay? So then it becomes optimized. There's no delay anymore. Okay. Perhaps another picture. You have a power plant, you have a turbine. Okay. Then again, our favorite control loop, inputs, controllers, and outputs. So okay, for example, for this one, our sensor sees that, hey, the turbine is very hot. The mechanical parts are hot. Or the vibration is very strong. Okay? So it goes to think there. Controller says, hey, you need to slow down or you need to stop. You're too hot. Or maybe on the cooling system for it to cool down. Then we keep doing it again, right? Sometimes we get alarms, but it just does it control loop. Now we put another business insight with, then, what? Oh, sorry, ignore the poll for price and the price forecast. It was a copy-paste error. Okay, what if we bring this vibration info, this temperature info, pressure maybe on the valves of the cooling system of the turbine, okay, a lot more, just pump it in. Since we can all read it, right? Pump it to the cloud, we have some smart guy there, apply some data analytics, and get a predictive maintenance. So now, how do we maintain our power plant? Normally, okay, our turbine, every 6 months we maintain. Oh, that is just some number I pulled out, okay? I'm not a turbinist. Every 6 months, we maintain. So periodically we maintain. But now we introduce this predictive maintenance, tell our controller that, hey, you know what? I know it's already 6 months, but you're still good. You can still run. Okay? Actually, I can predict that you need to do maintenance 8 months from now. So you still have 2 months. Okay, you do the math, you do the economics, you save 2 more months, right? Instead of doing predictive maintenance on what doesn't need yet. Okay? So then again, for me, the smart factory knows when maintenance is needed. Okay? So the word again is optimize. Okay, so for me, actually not really for me, this is something I researched also. Smart factory does optimize. So now, okay, after knowing that, we go around and we hear a lot of buzz. Right? Buzzing. Bzzz, people buzzing. Okay? So maybe on this group, there was a buzz. Smart manufacturing. Smart factory, smart manufacturing. Bzzz, we always hear this, right? Actually, I googled it. I cannot find smart factory. What I can find is smart manufacturing. So, after looking at Google Wikipedia's definition, I still see the optimized word. But I guess you have a better foundation with this one after Mr. Tol gave his talk, right? Okay, then again, okay, we want to be smart. What else? Hear a buzz again. Bzzz. Oh, Industry 4.0, people are talking about, right? Thank you again, Mr. To. You covered me the fundamentals of Industry 4.0. Okay, maybe what I would just want to say is that Industry 4.0 is the revolution that will give birth to the smart factory. So this means we have to follow Industry 4.0. And in this way, we will achieve our goal of having a smart factory. Okay, buzz, buzz again. Then we hear, okay, Industry 4.0. And we see this building blocks of Industry 4.0. This was a great seminar because we learned about autonomous robots, right? We had an idea of big data analytics. Additive manufacturing were mentioned, cybersecurity, okay, were mentioned. But what we concern here more about, the buzz, is we hear here. The Industrial Internet of Things. So this is the third buzzword, the Industrial Internet of Things, which for me, an engineer, is just get the things connected. That's all. So, moving on, are we talking about these things? Your car, your fridge, or your washing machine? No, no, no. Us is industrial, right? So we're actually talking about the cloud connected to which things? PLC. Is there anyone here who doesn't know a PLC? Hopefully everyone does. If not, you ask your seatmate. Process meters. These are like power meters. You know, power meters wherein you monitor the consumption of your electricity. Touchscreen. An operator interface you connect to your PLC. Because you cannot go to your PLC and press it. Right? You need to have a touchscreen. IP cameras, SCADA. Okay, you have a lot of PLCs. Yes, they have touchscreen, but do you go around and monitor the 10 touchscreens? No, right? They're all consolidated on one device, which is the SCADA. And today, we learn about robots also. Okay?